We're familiar with fatty acids, which I have drawn right here. Remember, the R group just means whatever chain. So for a fatty acid, there would be a big, long chain on each of these. We know fatty acids, but we've heard of fats and oils. Fats and oils are a combination of glycerol with a fatty acid. Here's glycerol and here's fatty acid, and they can do a condensation reaction. Remove a hydrogen here and a hydroxyl there and join them together, and you get this kind of bond. Okay, notice there's 3 hydroxyl groups, so 3 fatty acids can be attached. When we get that, it's called a triacylglycerol or a triacylglyceride, or sometimes just a triglyceride. All fats and oils are triglycerides, and they have this structure. What differs between the fats and oils is the length of the chain here and whether or not it has double bonds and what type of double bonds that it has. We define fats as being a solid triglyceride and oils as being a liquid triglyceride. So it really just is the melting point that we're looking at. This melting point is determined by the length of the carbon chain, the type of the double bond, and the number of double bonds. The longer the carbon chain, the higher the melting point. The more double bonds, the higher the melting point. And then trans double bonds have high melting points, and cis double bonds have low melting points. So, the melting point, carbon chain length. Longer chains have a higher melting point. So something like coconut oil has very short chains in it, and so it has a low melting point. But then I look at, let's say, beef fat. It has a very long carbon chain, so it has a high melting point. If I look at a trans fatty acid in a fat, you will see that those have high melting points, and cis double bonds, those are what make oils. The more cis double bonds you have, the lower the melting point. So a polyunsaturated fatty acid would cause the oil to have an even lower melting point than one that's monounsaturated. Fats come from animals. Animals make mostly saturated fatty acids that have long chains, and so they tend to be solids. There's the double bonds are missing, so we have a high melting point. And the problem with solid fats is in your bloodstream, they can form solids in your where you have high pressure around your heart and up in your carotid arteries, which cause blockages that we know as strokes or heart attacks. Oils come from plants, and plants make mostly unsaturated or short chain fatty acids. The short chain fatty acids are palm oil and coconut oil, and things like corn oil, peanut oil, they have unsaturation in them. If it's just one double bond, we call it monounsaturated. If there's more than one double bond, it's called polyunsaturated. The double bonds in plant fatty acids are cis, and so they have a low melting point. And of course, short chains have low melting points. Oils do not tend to form solids in your bloodstream, so eating oils instead of fat helps to prevent blockages that cause heart attacks and strokes. Trans fatty acids do not occur naturally. These come from a food manufacturer doing a partial hydrogenation. And what happens when the partial hydrogenation is done, the cis bond flips to a trans bond. But food manufacturers don't like to have cis fatty acids in their food because they have a short shelf life. They are easily oxidized, and they give food a rancid taste. So They tend to use hydrogenated or partially hydrogenated oils, but trans fats have a high melting point. An example is Crisco. It has a high melting point relative to oils. These tend to become solids in your bloodstream where you have high pressure around your heart and your carotid artery, and these also cause strokes and heart attacks. So here's an example of a fat. It's mostly long chains that are unsaturated. You have one cis double bond in there, but it's not enough to make it a liquid. Because they can stretch out and be flat, they have a low melting point. Excuse me, high melting point. Oils tend to have a lot of double bonds in there. The more double bonds, the lower the melting point. And notice that it causes these things to crumple up, so they don't stack easily, so they have a very low melting point. You have to get them very cold before they solidify. Steroids are natural products. There are some synthetic ones that tend to get headlines in the newspapers, but steroids are primarily a natural set of lipids. Lipids are those things that won't dissolve in water but do dissolve in nonpolar solvents. These are a natural group of lipids that have the same structure that you see without. What differs is what's attached to the structure. So you have this four-ring structure that makes up a steroid. Here's an example. Cholesterol is a steroid. You see what we call the steroid nucleus right here, these four rings attached together. Now, cholesterol has this long chain here and an all there, an alcohol group. Estrogen, aldosterone, testosterone, they're all steroids.